Hello everybody. We have finally made it to the point in this series where we have laid the foundation for our program. So I'm happy to say that the videos going forth from now should be a lot shorter than the previous ones. So now everything else will just be small additions that could be made in videos that could be hopefully 10 to 15 minutes long instead of 30 to 45 minutes long. Now the only videos from now on that could take a long time are when we get into the servers and creating all of the, message packets that need to be sent between more games, or when we finally create multiple instances for the game so that we can have two players play on the same field. But those will be special videos that I think you will enjoy, and they will need to be that long. So in the last video, we created the following animations. We drew our prize cards, and then we drew our hand. So in this video, we're going to do two things. We're going to learn to set the cards onto the field, and we're also going to input all of the card information for every single card. Now, that might sound like a lot, but it's not, because I've done all the work for you. So all you need to do is just copy and paste the card information at least. I'm still going to walk you through everything and my logic behind everything, but I'm going to try to cut all of the unnecessary stuff out. So if you see when I click on a card that it prints out this information, this is only to test that all of the information is in there so that we can see that we've actually stored it correctly. Now, you see that this card doesn't match the card information up here because I have a Charmander in my hand. That's because we gave this card the card number 1, and this card the card number 2, and this card the card number 3. In the original base set, the first card was Alakazam, the second card was Blastoise, and the third card was Chansey. Now, what we're going to do first is get our cards to be set onto the field, and then we'll get into that. So one thing I want to address before I actually move into this is something one of the viewers pointed out. They didn't like that if you move the mouse too fast, it would drop the card. Now I'm going to adjust that in this video so that we won't have that problem anymore. So let's begin. So in order to fix that problem, and let me show you on the actual program so you kind of see where the issue is. So this is our current program. So if I start the program up and I move this card, if I move it too fast, you see it falls out of my hand. That can be very frustrating. The reason why I allowed that to persist, even though I knew that was an issue, was the original card game I created was intended for a phone app. And when you're playing a card game on your phone, you're not worried about jolting your finger across the screen. You usually play it with your thumb, and you'll probably move it this quick. And it wouldn't matter that the card would drop because you probably wouldn't move your finger that fast. Now, in order to eradicate this problem, the first thing we want to do is open up our card object. So what causes it to do that is this mouse leave event. Whenever it leaves, it sets the selected variable to false. And whenever that is set to false, the card will no longer follow the mouse X and mouse Y position. So what we want to do is we actually want to remove this so that when our mouse leaves the object, it will not set the selected variable to false. So getting rid of that will prevent it from doing that. And then the next thing we want to do to ensure that the object will maintain the mouse X and mouse Y position is copy this text from this left down event and move it to the draw event. So now if we start the game and drag one of the cards around, Now, what will happen is when we drop the card, we can see that it will fall back and kind of act the way it should act. Now, when you create a game, you want to make sure you test it until you break it. So I know an issue will arise with the code we did, and we have to adjust the game for that so that the player won't find any glitches in the game. So now what I'm going to do is I'm going to move this card so fast and release the mouse button so quick that it won't move back in its place, and it will follow the mouse even though my left mouse button isn't down. So let's see if I can do it. See that? So my mouse button isn't down, but the card is still following me. Let's try that again. See? So the reason why it's doing that is because the mouse is leaving the object before the left released event can compute. So what we need to do is, this is the left released event. It sets it equal to false. But now we need to make this happen even if the mouse isn't in the object sprite. So what I'm going to do is go to the step event and create a new condition. And that condition is if mouse check button released, mouse button left, selected is equal to false. And then I will remove this event because we no longer need it. So now let's test it. So let's start the game. We can still move it around. And no matter how fast I move it, no matter where the mouse is, it still won't follow my mouse if I let go too quick. So now let's get on to new additions to our program. So what we want to do now is set these cards onto our field. So the first thing we're going to do is initialize the new variables we will need in order to do that. So I'm going to initialize these field variables, and those field variables are going to be for i's equal to 0 and i's less than 6, because there's going to be 6 positions on the field, I++. So what we want to do is we want to allocate memory for each position in the field. And I'm going to initialize all of those values equal to 0 because there's no card in that position. And the next thing I want to do is create an object array for every card object on the field. And I'm going to initialize those to no one. So the next thing I need to do is figure out where I want these cards to be. So I'm going to start my game up, and I'm going to use that same tool we've used from the beginning to see the best positions for my cards. So if I drag this here, I can see that my object should be somewhere in this range. Now a lot of this will be trial and error. So I see that this says 152 and 421. Now I've gone through this enough times to know the exact position I want, but this is a good tool to help you find the range you need in order to find the right position. So I'm going to initialize the x and y variables for each position. and those variables are going to be called field x coord 0 and field y coordinate. So the first position, and I'm going to copy these over so I don't have to keep rewriting these variables. So since there are 6 of them, I'm going to paste it 6 times. 4, 5, 6. 0, 0. Because these are going to be 2 separate arrays, so I can give each position in that array will have the same corresponding number. So position 1 is going to be 158 and 428. The next one will be 158 and 629. And then the following will be 239, 629, 320, 629, 401, 629, and finally 482, 629. So these are all of the variables we will need to initialize in order to do this. So the next thing we'll need is an object for the cards on the field, because we're not going to use the same object for the cards in our hand. So the only thing I'm going to initialize for this object is one single variable. Selected is equal to false. And then I'm going to go to my object card and recreate the mouse left released event. So in this event, what I'm going to do is if the mouse is released, I'm going to check to see if the mouse X and mouse Y position are within the boundaries of each position on the field. So in order to do that, I need to run through each position on the field. And make condition statements to check if each card is within that boundary. So the first boundary I'm going to check is the X position. So if the X position of the card is greater than the field X coordinate minus the card width divided by 2, and the X position of the object is less than that same field position, plus the card width divided by 2, I know I'm within that X position boundary of that field position. So what you can tell from this equation is, or so the boundary that this equation will check is this right here. So I'm choosing the X position, which is the horizontal axis. It's going to go to this position that I set for this field position, and I chose the minus and plus the card width divided by 2 because the first instance of that condition statement is checking this position of that field slot, and then the next condition is checking the other half of that field slot. Now we want to do the same thing for the Y position, except it's going to need to check the upper area and the lower area. So if all 4 conditions are true, then we know that the mouse or the card object position is within this boundary. So now let's make the Y condition. going to be very similar to this. So what I'm going to do is I'm going to save some time and paste this, change the x's to y's, and change the card widths to card heights. So now that we know that the mouse or the card position is within that area, we can create a field card in that position. So in order to create that, we're going to set the array for the field card objects equal to instance create depth, and it's looking for an X and a Y position. We're going to use the variables we initialized, and the object we created. And I realize I never named this object. So let me do this now. And we see that it turned red. So we've now created the object. And the next thing we want to do is set the variables within that object. Now, if you remember, I only put one variable in that object. That doesn't mean I can't initialize more. So what we're going to do is we're going to pass it a few variables to match the card that we're dropping from our hand. So I need to create a few variables. I want to maintain the same sprite and the same card number. As well as the position we want to set the card. Now the next thing I want to focus on is this variable I created, cardNum. As you can see, I have two different variables with the same name. One is yellow, which means it's a local variable, and one's blue. I created these variables because I need local variables in order to pass them to another object within an object. So since I created this field card object, I would like to add variables from the object card, which is the object we're in, and add them into the object field card. So since these variables do not exist in this object, I need to create these local variables because I'm able to pass them to the other object. Now I could have chosen a different variable name for this and have been okay, but for the sake of knowledge, I decided to go this route, just so I can show you this self-designator. So what this does is says, even though I created a cardNum local variable, whenever I want to use the one within the object, I can add self period before any object, and it will choose, and it will know that I'm referring to the card number in this object. So now that I've initialized these variables, I can pass them. So one thing I want to do is create an object player variable, as we do in all of our other objects. Then I want to initialize this card number. Again, I'm using the card number variable within this object, and I'm going to set that equal to the card number local variable we created up here. Then I want to set this position equal to the local variable position. I want to set its coordinates and I want to set its sprite equal to the sprite of the card we are dropping. So what this will do now is create a card onto the field. Now this is preventing me from moving forward because I added an additional variable in this function call. Now I see I've only actually added 3, but it's saying that I've added, oh, it's expecting 4, so I missed one. I needed to add a depth. Now my depth I will just set to 1 for now. So now let's see if it will create an object to my field. So I'm going to drag this here, and as you can see, it created an object onto the field. So the object that's on the field is different than the object in my hand. Now what we want to do next is remove the card we dropped onto the field from our hand. So in order to do that, we need the following lines of code. We want to reduce our hand count. We want to set the position of the card equal to 0. Then we want to move all of the cards down 1, beginning from the card we dropped. So, and that might be hard to understand, but let me write out the code. For I equals hand position. So we're going to start from the card we dropped, and I is less than 7, because that could be the max amount of cards in our hand. So we want to go from our hand position to the last card in our hand, and then we're going to increment that by 1. We want to set the hand position equal to the card next to it, effectively moving the cards down 1 position towards the first card in your hand. So the next line of code we want to do is for our hand objects. So this will only address the hand variables in the object player, but we also have card objects that represent those variables. So what we want to do is change the position of each card object. So let me write this out and then I'll further explain. So if I is less than the player hand count, we added a separate condition statement for our card objects, because if I goes into a position where there is no card, and let's say there's a 0 there, this for loop will go through every possible hand position, even if there isn't a card in that position. Now, if we were to do that while we were altering our card objects, it will crash the game because an object hasn't been created for that position. So that's why we have this condition. And what we want to do is, with that object, with that card object, we want to change its card position variable. So we're effectively moving it down 1, just like we did before. We want to reduce its hand position down 1. And we want to reduce its depth to match that position. And then the last thing we want to do is destroy the card object we are dropping on the field. So again, let me clarify this line of code. This variable belongs in the object player, and these variables belong to the object card. So we want to change both of them so they constantly match. And then we destroy the object we currently dropped. So now let's see how that works. So that should have successfully allowed us to drop a card onto the field without adding the card back to our hand, and it readjusts our hand format to match the amount of cards we have in our hand. So now that we've done that, I want to add all of the information we need for every card in the first set of the Pokemon game. So this won't take long because I have already written out the entire script so that it can just be copied and pasted into your project. So we're going to create a new script, and we're going to call it script init arrays, and then we're just going to paste all of this in there. This is 2,656 lines of code. Lines of variables we are initializing so that we can have every single amount of information of each card so that we can transpose it into our game. Now I will leave a link either in my Twitter or in the description below, so if you need it, just go there. If you can't find it, just leave a comment down below and I'll be sure to help you out. So as you can see, we have the first card, which is Alakazam, then it goes to Blastoise, and then it goes to Chansey. And the information I decided to pull from the cards are their card number, the name of the card, the stage, its type, its HP, the text for their attack, so the name of the attack and the explanation of the attack, the cost of the attack when it comes to their specific energy, any colorless energy cost, and the damage it does. I did that for 3 different moves, although I know typically a card will have a maximum of 2 moves, but I created an extra one just in case we ever need to expand to a 3rd move. I also included their weakness, their resistance, their retreat cost, and their rarity. And I did that for each of the 102 cards within the first set. So, in order to add all of those variables into our project, we need to add that script call into our objects. So I'm going to put script init arrays here. So now that this object has all of those variables, and I'm also going to do it to the field card, so that the field card will have all of those variables as well. So now the next thing we want to do is test to make sure that we have added all of the cards properly, because that's a lot of lines, that's a lot of variables. I could have messed up somewhere, I could have skipped a line, I could have not put all of the information for one card, which will knock all of the other cards out of whack. So I want to test that. So in order to do that, I want to print out the information. And in order to do that, I'm going to create a new script. I'm going to call it script draw card info. And this will be another thing I copy and paste because it's a lot of text. So I'm going to zoom in and explain. So what this is going to do is going to take in the card number of the object. It's going to create some variables that we are actually going to set as local variables. So that we don't mess with any of the variables in the object that this script call comes from. And I'm going to draw each variable for each card. So now let's add this into our objects. So in our card object, let's add the script draw card info, and we're going to pass it its card number. So now let's play that. Let's start the game, and if I select this, I can see the cards being drawn. Again, I made the text blue so that it could be easily read over all of the sprites we have in our room. So I can see the first card is Alakazam, the second card is Blastoise, and the third card is Chansey. Now, if I want to test every single position, what I'm going to do in my left release button, every time I click on it, I'm actually going to increase the card number by 1 so that I can make sure each card prints out correctly. So since I have this local card number here for this event, I need to put the self designator before the card number up here because I want to change the card number in this object. So now let's see what happens. So I'm going to start the game. I'm going to click on Squirtle because he currently takes the first position card number. If I click on it, it's Alakazam. If I click on it twice, there's Blastoise, Chansey, Charizard, Clefairy, and etc. But feel free to go through them and match them with the card itself so that you understand kind of my thought process in doing this. So what I want to do is I actually want to delete this because if you click on it too many times, if you click on it and it goes past 102, it'll crash your game. So this is where I'm going to end this video. In the next video, we're going to work on adding all of the sprites for all of the other cards in the base set and adjust our code so that Squirtle, Charmander, and Bulbasaur aren't the first, second, and third cards in our inventory. So what I advise you to do is go to my Twitter. I have uploaded a document to Google that you can find in a link I shared, and you can get all the sprites you will need to do it. Now, this is a cumbersome task, adding all of the sprites, so I recommend getting a head start. If you enjoyed this video, please hit the like button. If you have any questions, please leave a comment. If you have a hard time finding either the list of all of the card information needed to import the information into our program, or if you are having a hard time finding the sprites, leave a comment down below or find me on Twitter. Don't forget to hit the subscribe button, and I'll see you guys next time.